Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So today we will going to see these topics: inverter, AND gate, NOR gate and XNOR gate. Let's get started with inverter. So here is our problem statement. Create a module that implements a NOT gate. So everyone knows what the NOT gate is. It just inverts the output. So we will see the code. So here expected solution length is around one line. So let's get started. We have to write assign out equal to, we have to invert the input, so the symbol is this one for inversion, and we have to invert the input, so in and semicolon. Let's submit it. So here you can see the compiling process has been started. So as you can see, the timing diagram is correct and there is no mismatch in our output. So let's get to the next one. So next one is AND gate. So let's see the problem statement. Create a module that implements an AND gate. So here is the explanation, you can see. So AND gate is a basically gate which when both the inputs are true, the output is true or else false. So we have to implement the AND gate here. So expected solution length is around one line. So in Verilog there are two types of operators, like logical AND operator and bitwise AND operator. So you can use any one of them because we are doing here for just a bit. Let's see. Assign out equal to a. This is the symbol for bitwise AND, and this is for logical AND. So we're doing logical. So let's submit it. So compiling process has been started for the AND gate. So as you can see the timing diagram, there is no mismatch and the status is success. So let's move on to the next one, NOR gate. So let's see the problem statement. Create a module that implements a NOR gate. And so here they have given the definition. NOR gate is an OR gate with its output inverted. So everyone knows about the OR gate. Whenever the one input is true, the output is true or else false. So NOR gate inverts the output of the OR gate. Let's get going with the code. We have to write the assign out equal to, we have to invert the output of the OR gate. So inversion symbol, bracket a. Here also, like AND gate, there are two types of operators, like logical operator and bitwise operator. Logical operator logical or performs the logical OR operation for the whole given value, and bitwise or performs bitwise OR operation. So let's get, this is the simple. Let's submit it. As you can see, compiling process has been started. No mismatches. So the status is success, and here are the timing diagrams. So let's move on to the next one. XNOR gate. XNOR gate. Create a module that implements the XNOR gate. So we know the truth table of XNOR gate, that when both the inputs are same, the output is 1, otherwise false. So let's see the code. Let's check out the code. Assign equal to inversion of XOR A XOR B. Submit. So now the compiling process has been started. So as you can see, the status is success and timing diagram. There is no mismatch. So next Sunday we will see about declaring wires N7458 chip.